Good morning, everyone. Right, before we get started, I want to do something to get the energy up. So give a round of applause and cheer for the conference, all right? Woo! Perfect. All right, so we're going to talk about improving C#, or improving us when we're doing C# development. My name is Filip Ekberg, and we'll be talking about some of the changes that are coming to C# as a programming language and how that can make us as developers a little bit better. So at the end of this talk, we'll all go away and be F# developers. In all honesty, though, C# has over the years taken a lot of language features and inspirations from programming languages like F# and Swift and Java and C++, and all of those different paradigms out there. Over the years, we've got features into the language that kind of help us build better software. You know, with C#2, we got generics, and with C#5, we got async and await. And they changed the way that we build our software. Because if we look at building software in 2020 or 2019, it's a little bit different than building software in 1995. I think most of us would agree that it's a lot easier, or maybe it's a lot harder for us to get accustomed to the new frameworks and all of that as well. But C# is trying to make it a little bit easier for us to tackle these different problems and make it easier for us to build code that's maintainable, testable, and easy to get into. So with C#8, there's coming a lot of interesting features, and it's things that potentially have been available in C#6 and 7 and so forth, but it's changing the way that we write our code. So in order for us to get started with all of these new nice features, we need to jump into Visual Studio 2019. What's interesting is that last year I was here talking about C#8 and beyond, and some of the features that they were potentially adding to the language. At the end of the talk, I said that don't be mad if they cut some of the features out of the language. And guess what? They cut most of them out and added new things. They also said that they were going to add C#8 and .NET Core 3.0 to Visual Studio 2019. But guess what? They didn't do that either, so there's that. They did, although, ship .NET Core 3.0 in September this year. And with .NET Core 3.0, they also released C#8. So why do you think they couple those things together? It's because C#8 relies on .NET Core 3.0 for some of the language features. Which means if you're on .NET Full Framework, you can still compile some of the features using C#8, but most of it is unsupported. So that's a little bit problematic. So if we're doing, for instance, Windows development, what they had to do was make sure that we can now build WPF applications using .NET Core. And we can also do WinForms applications using .NET Core. Also, although it's not just a drag and drop thing to convert your application into .NET Core, but you can have the potential to do that. What's interesting with changing the runtime is that they can now do language features that were harder to do in the past. We all know that throwing away a code base and rewriting everything from scratch is the best approach out there. Just remove the dependencies from the past, and it'll be easier for continuing to add new features. One of the features they're adding to the language, and some help in Visual Studio to tell us that the feature is potentially not available for that particular runtime, is this default interface implementation. We'll get into exactly what this is later on, but what's interesting here is this little box here that tells us that this particular language feature is not available in that runtime that you're now targeting. So it's interesting that we can turn on the C#8 features for .NET Full Framework or earlier versions of .NET Core, but when we try to use the features that require the new runtime, it'll tell us that you should potentially just upgrade your project or don't use the features. So I don't want to spend too much time in PowerPoint. I want to go into Visual Studio and talk about how C#8 is improving the way that we build software, and talk about how C#7 introduced some of these features and how that's changing and why they didn't improve on them at the start. So two of the features in C#7 they introduced was Tuples or whatever you want to call it, and pattern matching. Now, these two features were added separately. They don't have anything to do with each other in C#7, but in C#8 they kind of tie these nicely together, and we'll talk a little bit about that as well. So Tuples has been around in C# for a very long time, but it was kind of tedious to write tuples. And honestly, when they added these language features in C#7, I was like, oh, why did you do that? Because it doesn't make a lot of sense. But of course, someone smarter than me thought about the future and thought about, we might need this in C#8. So a tuple is a way for us to represent a collection of fields, or not a collection because that's kind of talking about a list of things, but it's this bucket of fields, right? So you can look at this as, you could potentially have a class instead, or you could have a struct. But the tuple here allows us now to say that I have these two fields in this bucket of things. I can represent my object or whatever I want as a tuple, and I can all have more values if I want to. I could have another one, and I can have a tuple with as many fields as I want to. So that's a little bit interesting. And the way that we can use this is that we can also couple this with something called deconstruct, which was also introduced in C#7. It means that we can take one tuple, deconstruct that into looking like something else. So you'll see here that I have this method called queued interaction. Now, queued interaction here is simply returning a tuple, a name tuple, where we have two fields, one field called state and one field called operation. I pop something off a list of interactions. So this system here is kind of a state machine. It's working with, I can open and close doors, and depending on if it's already open, locked, or closed, I'm allowed to do certain things. So I have a stack of operations that I can do in my application, and this here simply pops the next operation that I want to do. What's interesting here is that the thing that I get out of pop here, when I pop out of this thing here, let me just change to the correct language so I know how the keyboard works. What you'll see here is that when I pop from this thing here, we'll get an unnamed tuple. So what it's doing is that it deconstructs this thing into a named tuple, and it does that by positional matching. So it takes the state that I get and put that into this particular tuple that I have here. Because if I use this right away, we'll let item 1 and item 2 like we've done in the past in C#8, but that's kind of tedious to work with, right? So we can now use this and leverage this name tuple instead. And what's interesting is that I can call this queued interaction method, and C#7 will automatically allow us to just leverage this tuple. I can map this tuple to a local variable in my main method here. So I can say interaction dot, give me the operation, and give me the state. So I have this named tuple that I can work with. And we can deconstruct this in different ways. I can say, give me the result of this, give me the tuple, and deconstruct that into this new thing here. So we take the tuple and deconstruct that into something else. And this thing here tells me that I don't care about the first thing that you're getting out of this tuple. I only care about getting the operation. So this was an interesting feature added to C#7, but I don't know if I would ever use this if I were only working in C#7. So this alone here doesn't make a lot of sense. So they added this as a language feature. I don't know if anyone used it in C#7 in a production environment, but when it becomes really interesting is when we couple this with pattern matching that they're improving in C#8. So speaking of pattern matching, that's the second big feature added to C#7. They added a whole bunch of more things, but these are the two interesting things that I like. Look at this code here. So what this code is doing is that it's looking at a particular object that I'm getting. I'm getting this shape out of my program. I'm saying if the shape here is a triangle, I'm going to cast this triangle because I don't have it as a triangle, so I'm going to cast it to a triangle. If the sides are equal, I'm going to return this string here. Otherwise, I'm going to return this. If it happens to be a rectangle, I'm going to cast it to a rectangle. And this code becomes a little bit tedious, right? So with C#7, we could improve this upon a little bit by introducing pattern matching. So let me comment this out. And what we can do instead, we can convert this into using a switch instead. So we can now say that based on the shape that I have, I'm going to run this switch block, and if it's a triangle, I'm going to capture that as this local variable of t inside the scope of that case. So this syntax is a lot nicer. Of course, we have other approaches that we could do with the first if and else blocks. We could, for instance, apply the chain of responsibility pattern and make that nice as well. But again, this is a much nicer approach. And with C#7, we also got this notion of applying the condition here, like we've seen with the exception filters. So we can say, if it's a triangle, I'm going to capture the triangle in this local scope here. And then I can do the comparison, and I'm going to return that string base of that. If it's any other triangle, I'm going to do this. If it's a rectangle, I'm going to do this, and so forth. So that's a nice addition to the language. But comparing pattern matching to other programming languages like Kotlin or F#, there's still a few things that we really want to get out of the language. Now, even though this reduces the amount of code that we write, it looks a little bit nicer, and it's probably easier to continue working on. There's still a few things that we could ask out of this code here. So how about we look at the things that they're now improved in C#8 to make this a little bit better. Now, the same example in C#8 can look a little bit different. We can still write the same thing. The new language features, you don't have to use them. They're just making your life a little bit easier. So what they've introduced in C#8 is two things when it comes to pattern matching. They've introduced something called recursive patterns, which is a way for you to look at the particular object. Pattern matching allows you to look at the traits of the object. Not only this is a type of, but you can also look at what kind of properties do you have on this object, what are the values of the properties, and how do I deconstruct this object and look at different types of values that you deconstruct this into. Sounds like a lot, right? They also introduced something called the switch expression, which is a nicer way for us to write a switch statement as an expression. So let's look at that. The exact same approach that we had in C#7, we can now write using this switch expression. So I can say, based on my shape that I have, I'm going to create this expression, which is now a switch block. We have an expression here, or we have a case here, where if it's a triangle, and when the sides are equal, we're going to return this string here. And we've seen this being used in expression-bodied members. So why would you write this syntax instead? Because you can now use this with other features earlier released in C#, like expression-bodied members. So we could, for instance, take this entire thing, and we could, for instance, have a property up here, or something, right? We could have an expression-bodied member. That's what I want to say. It's not a property. But we can do this, right? Which was harder with earlier versions of. You get the point, right? So we could use this as an expression-bodied member without introducing the body for that method. Reduces the amount of characters that we have to write, and potentially makes the code a little bit more readable. Really depends on the developer. You can abuse all of these features if you want to, but you probably shouldn't. Now, a little bit more of a real-world scenario where this becomes interesting with tuples. So remember I said they introduced tuples in C#7, or a better way for us to use tuples. Now what we can do is that we can leverage tuples as well as pattern matching to create even less readable code. Depends on the developer, right? So in this example here, I built the code, so therefore it's obfuscated by default. So imagine I have this method here. It takes an order, and based on the order, I want to do certain things. If this order is canceled, I don't care about capturing that particular order. I don't care about leveraging any of the properties. So I use this discard notion. I say that I don't care about that, capturing that as a variable. And I'm going to return a new status for this shipment to mark this as the order needs to be returned, right? If it's a finalized order, and then something, we're going to mark this as shipped. What's interesting is this something that we have here, which is pretty much looking like a tuple. So now we're leveraging the C#7 feature in C#8, which is the tuples. But what does this really have to do with the pattern matching parts? Well, first of all, we look at the particular type of the object when we're matching against a particular pattern. And then what we're doing is that we're recursively looking at how do we deconstruct this object. So how do we know how to deconstruct an object? Well, if we take a look at the implementation of the finalized order, both of these just inherit from the same base class. But what I've done here is that I've introduced this deconstruct method. Right? So I've introduced a method called deconstruct, and that means that now C# can automatically just deconstruct this here into a tuple. When I get a tuple out of this, I will get 4 different values. I will get the shipping status, the payment status, the amount due, and the line items on this particular order. What that means is that whenever I say, in pattern matching, when I say if it's the type here, and then how do we deconstruct this, it's going to recursively take the object, call the deconstruct method, construct this tuple here, and make sure that we can match this particular tuple value that we have here. Sounds very complex, but it's really not. What's happening here is that we get a tuple out of the deconstruct, and then it's using a positional pattern to match that the first value is marked as shipped, and I don't care about what the other values are. Right? So that means that deconstruct returns shipping status as the first parameter, and I don't care about the other ones. what it's doing is that it's pretty much just saying if the shipping status on this thing here is shipped, if we can deconstruct that, and the first position in the deconstructed element, or the deconstructed tuple, is now marked as shipped here, we're going to run this statement here. Then I can say, another way of expressing ourselves is saying, I don't care if this is a finalized order, if it's a canceled order, or if it's any other type of order. If you deconstruct this object, and the deconstructed thing matches this tuple here by positional pattern matching, we can now say that I want to run this block here. So this means that if we deconstruct the object and the shipping status is waiting for payment, the status is now marked as being paid, we're going to mark this as being ready for shipment. Now where it becomes a little bit more interesting is when we introduce something called a tuple pattern together with this positional pattern. So we deconstruct the object, we say that I want this to be marked as ready for shipment, the order is partially paid, I'm going to grab the amount due as a local variable in this particular case here, and I'm going to say when the amount due is less than 200, I'm going to ship it anyways, because I trust that my customer will then pay this by invoice. Makes a lot of sense, right? And totally makes the code unreadable. But it does improve the way it's like, imagine building this without this nasty switch block that we have here. Right? Another way that we can do this is to say that for all orders, as long as this third parameter, which I have no idea which one it is, I know that it's amount due. But if it's marked as 0, it's ready for shipment. Now you're probably thinking, well, I can't just go ahead and add a deconstruct to all the different objects that I use. Sometimes I don't own the object that I work with, right? We use NuGet packages and so forth. So what we can do is that we can use something called a property pattern, which is allowing us to say that when this is a finalized order and when the property amount due is 0, we're going to mark this as ready for shipment. So this property pattern here allows us to point to a particular property on this class. So it's recursively looking at, first it's looking at what type of order this is or what type this is. And just one point, they don't necessarily have to inherit from the same base class, but in this case they do. And then we are checking that particular property value, and if it's 0, we are ready for shipment. And then what we can say that for everything else, we're going to wait for payment. Like if you pass a null here, if you pass a string, whatever order would be here, like it could be any object, right? We just use the discard and say that for everything else, we're going to mark this as waiting for payment. So this here certainly has the potential of us improving the ways that we build our applications and the way that we express ourselves in code. And I've been using this a lot, especially in other programming languages where it's been available for a long time. And I think F# developers would agree that this is a really nice addition to the language. Now, of course, I want to show a way to abuse this. So we're going to do this real quickly. We can say that we have a Boolean that's nullable because we all know that Booleans have 3 different values. It's true, false, and null. So in this case here, I can abuse this language feature and say that if it's true, we're going to mark this as visible. If it's false, it's hidden. If it's everything else, it's going to blink or whatever. So don't do this. I see developers do this in other languages, and it just messes things up. It would be easier to just have an if and else block. Now, another real-world scenario where we can leverage tuples with the pattern matching improvements is that we can, for instance, construct a tuple on the fly to say that I want a new tuple that looks like this here, based on the status code and based on the Boolean is successful status code on my particular HTTP response message. I'm constructing this tuple here, and I'm running a pattern matching on that. And then when using both positional pattern and the tuple pattern to say that if the tuple that I have is marked as not modified and the status code is true, we're going to read this from the cache. If it's 200 OK and I don't care about what you say the successful status code is, I don't know that it's true, but still have to have this discard here. We're going to extract the shape out of the message. For all of the other status codes where I don't have the particular status code, but I know that it's marked as successful, I'm going to do the same thing and extract that out of my HTTP response message. If it's a request timeout, and I don't care if this is I don't know if it's 200 or if it's a 300 or 400 area, I probably know, but we could discard that as well and don't care about the second one and say that you would probably then want to ask for that particular thing again. If the request times out, you might recursively want to ask for this again and run this code here. In a real world, you would probably introduce some backoff and don't kill your API like this. I've done that, and it's not appreciated. So that's the pattern matching improvements. Now, the recursive patterns will allow us to write less code that more easily express the way that we want to do something in our software. Another way to more easily express ourselves is when we work with collections of data. So another improvement they're making that really hasn't been available in the past. Or we've done things like using link to achieve the same result. Now imagine in this case here, in C# 6 or 7, if I want to grab all of these elements, how would I go by that? Well, I would probably say data.skip 5 and then take data.length minus 1, for instance, right? Or whatever I would write. This here would not do what I wanted to, or maybe it will, who knows? I know that this will throw an exception. Anyways, you would probably write something like this, and that's a little bit tedious. So how do we express this? In other programming languages like Python, they have built-in notions for saying, I want to specify a particular range of things, right? I want to be able to leverage the array syntax to say that, how about you just give me all the elements from the 5th element up until 1 off the end? That's a nice addition, right? So that here will give us 5 through 8. So the last thing here, the hat syntax, means that start off the end and then go 1 back. So if we want all the way to the end, we can do this to get all the way through the end, or we can say 0. If we do -1, we're going to get an exception, because that doesn't make any sense. But the compiler doesn't complain for some reason. All right. So that's the range syntax. And for those of you that don't know what the span of int is or span of t is, it's a way for us to look at data and operate on that particular data without having to do copies of the array or the collection of data. So now that I slice off this span of numbers, I say that give me a slice from 5 to 9. Normally, if you do this with link, you would get a new array where the values would be copied over to. In this particular case here, we just get a pointer to those particular elements, which is super fast. And they've leveraged this internally in ASP.NET Core and in all the other core projects, and it's improving performance a lot, since you don't have to do the copying and things, right? And of course, we can do this inline with a for each loop to say, well, for all the numbers in the range of my data collection from 1 to the end, I would probably write this instead if I want to express that, but we could also say data divided by 2, or data.length divided by 2, I think. Hopefully that works. So you can say, give me everything from the 1 element off the start until the middle of the array. So you can do a whole lot of cool things with the ranges and the range syntax. And the way that we express ourselves is by creating these indices or an index. So an index is this, for instance, the hat syntax, or if we simply have an index, we can probably say that we have an index of 1, and then we can start 1 off the start and then go up until 1 off the end, right? And we can leverage the variables here in that range syntax as well. If you've done Python, this is very similar to the ways that you do it in Python. So if you're working with large collections of data or ML or other types of projects like that, this is certainly going to improve the ways that you work with those particular types of features. And what's nice now when I talk about these C#8 language features is that we all know that they're available. We don't have to imagine that they will be out in half a year. So the next one is a really big one. One of the biggest problems with C# from the start was that they introduced null in the language. And they've talked about how do we make it better and how do we avoid null reference exceptions. And some of the things that we've gotten over the years is null coalescing things. We can say that if this is null, don't go ahead and get the value by using the question mark. And it kind of messes up our code a little bit. So they've understood that it's potentially problematic to allow nulls in a programming language. Why not do like, for instance, in Kotlin, where you have to opt in for things to be null? So we can do that now with C#8. We go into our project file if we want to enable this new feature called Nullable Reference Types. We go into the project file. We add this thing called Nullable Enable. This will now make our solution, or our project in this case, look at reference types as non-nullable. And that's pretty cool. Does that mean that we're now going to get exceptions everywhere that we use the null literal? No, it doesn't mean that we're going to get exceptions. It means that it's going to tell us that you potentially have null reference exceptions. I'm going to save this here, and I'm going to go into my program file or my code here, and we're going to go ahead and have a look at this person class here. Now, what's interesting here is that I enabled this feature. And compared to older versions of C#, this now tells me that there's a potential problem with this constructor. It's telling us that, well, you have a non-nullable property. And this is uninitialized, and you will potentially have a problem here. So that's pretty cool. So it's now telling us that you might have a null reference exception. So how do we fix this? Well, one way of fixing this is to say that, well, I'm going to ensure that my class here will never have a name of the person that's not initialized. But the problem with this here, we saw that the error now got away, but the problem here is I now changed the contract to whoever's using and leveraging this particular class. And that can be a little bit problematic. So in order for us to get rid of the error or the warning without going ahead and changing the interface to whoever's using this class, we can now say that my reference type here is nullable. Right? So name here can now be uninitialized, and the error got away, and we still have a null reference exception. So, how do we now know that we might have problems elsewhere? Where? Well, if we compile the project, we're going to get warnings telling us that you have potential problems, and we can scroll up here, and we see that inside this method here, I take a person class, which now by default is non-nullable. So I know that the person here isn't the problem. We get a warning here that's telling us that you have a potential dereference, a dereference of a possibly null reference. The way that we fix that is by leveraging older language features, which now allows us to say question mark here to say that if this is null, don't go ahead and get the length. And now we got rid of this warning as well. Another way to approach this is to say that, well, I'm going to guard this method here and make sure that this variable isn't null by saying if person.name is null, or I think you can even do this, right? So if this here is an object, totally makes sense. I love this syntax. So we can do this, and now the error got away. And our code is much more readable, right? We're now better developers. At least we protect ourselves from a potential null reference. And the problem, if we go back a little bit, the problem with this approach, the problem with using the question mark here is that this would now print null to the console, and that might not be the behavior that we want. In some situations, we might want to, really handle the potential null instead of just going ahead and printing something out or saving something even if it's null or not. In some cases, it's better that it throws an exception so we can go ahead and handle that. Then we can do something else. Imagine that person.name here, or the name of the person, is in fact initialized. I know that it's initialized later on. So at this point here, I know that it's been initialized, but the compiler isn't smart enough to understand that. I can promise the compiler using this dammit operator to say that this is definitely not going to be null. And that's great, right? But then we have another interesting issue here. So we can do that. We can tell the compiler that we know better. We compile this, and we no longer have any exceptions. But I can see here that I have this nullable person, which I'm passing into this method. I could use this new null coalescing assignment to say that, well, if person here is null, go ahead and initialize that to a new person. This here is just a little bit of a nicer syntax of the previous version of doing this, right? So we cut down the amount of characters by a little bit. They're also going to add something like this, right? Which I have no idea what that's going to do in this case. All right, so now the error got away, but I want to show you something a little bit more interesting. We have this nullable person here, which is coming from somewhere else. So this is perfectly fine, but I promise that this person here isn't going to be null, and I no longer have any problems in my application. Or do I? This here is definitely going to throw an exception, right? Because I'm definitely saying that this is null up here. So how about we go ahead and fix the problem, or the root cause of the problem, which is this particular null up here. So we want to make sure that person here is non-nullable. So we remove the non-nullable here, and now we know that person down here is probably not going to be null. Well, it knows it in this case because I'm using the literal of null. But you know, I can promise that null isn't null, so then the error goes away. All right, so that's the null reference types. So no, the features aren't really going to save you all the time, but in most of the cases, it's going to help you build better software. And comparing this to how we use this in C#, or we couldn't use this in C# 6 and 7, but compared to the ways that we did earlier, this here will now potentially tell us that we have problems that we didn't have earlier. So one more thing I want to show you is that with this feature, if you just enable this on your entire project and compile that, if you have use warnings as errors, you might get like 1 million errors. Because there are a lot of cases where there is a potential null reference exception, but you know that you've designed your software so that either you don't care or you're never going to reach that point. At least you think you won't reach that point. So one of the things that we can do is that to get rid of this warning here, if we know that this case here is not something that I want to handle right now, we can use this compiler directive to disable the nullable feature for a method, for a class, for a namespace, and we can use that internally here if we so like to, right? So I can disable that for this particular context. Which also means that I could disable it for the entire project, and I can enable this for just one method at a time, and I can start refactoring my application to make it better. So I really welcome this addition to the language. I think it's going to make our applications a little bit better. All right, so I have a few more features that I want to show you. I'm going to skip 2 of them because they're not as exciting as these final ones. We might get back to them soon. So, you know, async and await has been around now for a long time. In C# 5, they introduced async and await. In C# 6, they improved it a little bit. In C# 7, they allowed us to use the async and await keyword inside the main method of a console application. Because you might now have a console host for your ASP.NET Core projects, so it makes sense that you can now use the async and await keywords for a console application. But with C# 8, they kind of take it one step further, or like 1 million steps further, and now allow us to do things that we were not able to do in the past. So I've tried to do this in C# 6 or C# 7 ever since async and await was out. I've tried to work with streams of data. Imagine loading records from a database or loading something from the disk. Like you want to read one file at a time. And for each file, for each line in the file, you might want to process something or display that in your UI. Want to plot something out to a graph or to a diagram as you get the data, but previously that was a little bit tedious to write. Now they've introduced something called Asynchronous Streams, which allows you to asynchronously retrieve elements out of an enumerator. So what that means is that we have this for each loop. What I'm saying here is that I'm going to call this get method here, where the enumerator will asynchronously retrieve each item. And as I retrieve each item, I can go ahead and leverage that item inside this block here. I leverage this by adding the await keyword in front of the for each loop. So I say that for each element, I'm going to await that to then handle that inside the body of the for each loop. The implementation is rather simple. We have this new thing called an iasync enumerable, which is a task-like thing that now allows us to specify that we have an asynchronous enumerable. So the things that make this work is the async keyword, the iasync enumerable, the await keyword, and then the yield return. Yield return will communicate back to this enumerator that it should tell the for each loop that you now have an element to process. So in this very simple example, what I'm doing is that I'm iterating from 0 to 10. For each element, it takes about 300 milliseconds to process that element, and then I'm going to return that back to the caller, and then go ahead and process the next element. So that's pretty simple. Now, let's run this and see how that works, or what it looks like. And then we're going to look at another way of loading a file from disk. Hopefully the application still works. So you'll see here that it streams out the numbers to my console. I'm going to run that again. And you'll see here that we get each number just streamed out to the console. And I can go ahead and do this console write line as I retrieve the items out of my asynchronous stream of data. Another way of doing this as I mentioned, you might want to work with files or file streams. So here I'm using another feature that they've introduced in C#, which is the enhanced usings. So you'll see here that I have this using var stream is equal to a new stream reader. I'm pointing this to a particular file on my disk, but you don't see that I'm wrapping this thing in a using block that we had earlier in C# 6 or 7. Well, so when is this thing here disposed? It's disposed at the end of the method. So you can have multiple usings in your application, and you can now use this new way of specifying your using block or your iDisposables, and they will automatically be disposed of at the end of the method. And then what I'm saying is that for each line, we're going to read each line asynchronously, as long as we have lines to read. And then I'm going to process each line. It takes about 400 milliseconds to process. This is just imaginary. And then we're going to return that back to the caller. We'll leverage this thing here at the same way that we did in earlier versions of C#, except we now have the await keyword in front of the for each loop to say that we are asynchronously going to leverage each of the items. I'm going to run this here and see if you recognize the song. All right, so you've all been rickrolled by C#. So that's a really interesting feature. Now, the last feature I want to talk about, really, I don't want to show you this, but it's potentially going to help someone, and that's what matters. So imagine in this case here, I have something called an in-memory cache. It implements this cache that I have in my application, but I want to leverage a generic version. Because what this thing here is doing is that it's just saving this as a non-generic object in my list of cache or in my key value store. So I want this to work, but my iCache doesn't allow me to implement that. And I don't want to just add that to my particular concrete implementation of my memory cache. So how do we do this? Well, if we are a library developer, we might not want to just go ahead and add a lot of methods to our interfaces, because if we go ahead and add that to our particular interface here, that means that everyone that's leveraging my NuGet package will have to create an implementation when they update this. That's a little bit problematic. So with C# 8, and this requires .NET Core 3.0 or the runtime for .NET 3.0, we can now introduce something called default interface implementations or default interface methods, which means that I can specify this method that I have here. I can use an expression-bodied member to specify the implementation, again, on the interface. So this is just like a class, sort of, without the actual instance of the class, right? So I can't access the instance of that particular object. And then I can also do a normal method that we have, like we've seen in the past as well. So I have this add method. It's now generic. I can have this string as a key, and then I have this generic item that it's returning. It's just simply calling the older versions and just blindly casting that to the correct object. So hopefully it just works. But if I save this here and go back to my file, or wherever I use this, we have this as an in-memory cache, we'll still get the problem. It's telling us that, well, this doesn't implement that method. And the in-memory cache does implement the interface iCache, but we don't have the implementation for that particular method. That's all good, right? But if we change this to an iCache, we can now access that method. So that's interesting. This means that I can now add methods to my interfaces, and my classes that implement the interface have no idea that these methods now exist without actually checking the interface itself. The application compiles, and I didn't get any notification here that I don't implement that particular method. It's not telling me to implement this new generic version. So this is good, and it's potentially adding a little bit of problems, because we're going to get people asking us, well, you're saying that you've added this method, but it's not telling me that I should implement this. But everyone reads the documentation, so we'll probably be good. All right, so in all honesty, will C# 8 improve the way that we build software? Well, since we build software very differently from how we did it 20 years ago, it is certainly going to improve the ways that we find things like the null reference exceptions, the way that we work with asynchronous data, and the way that we work with expressing ourselves in software. So with all of these features added to C# 8, you can go ahead to this link here at the bottom, and you can check out all the language features that I didn't talk about. And it's just a bunch of really amazing things in the language, and they're still improving C# to be more adapted to more people out there. So hopefully, C# 8 is going to improve a lot of us when we're building our software. All right, so thank you so much for coming here and listening to this talk. I hope you enjoyed it. If you have any questions, ping me on Twitter, come up afterwards, or talk to me in the hallway. And thank you so much.